So it is a real pleasure to introduce David and his very interesting company. And we've had a lot of fun talking. And I'm really looking forward to this. Come on up and show us how it's done.
Good morning.
Give these a try. If they don't work, I'll help you with the slides.
All right. So a bit of housekeeping first. I have left the upper right-hand side open for the closed captioning, Dr. Norm.
Very nice.
And I don't think I will wander too far over here and get in the way, but I am aware of my height, so let me know if I'm in the way of
And
closed
you'll
captioning.
be off camera too if you do
I
that.
would, so anyway, all right. So I'm David Danneman. I am the managing member of Rosetta Design Group. At Rosetta Design Group, we do contract R&D and consulting using software to do protein structure prediction for development of drugs and vaccines.
Nope.
Slide, please. When you go to design a house or remodel your bathroom, something along those lines, you're going to reach out to an architect to do that design, make it look good. You'll speak to an engineer to make sure that the architect's design is functional, is not going to fall over in a couple of years. And then you'll reach out to a tradesman to actually do the work. The carpenters, the electricians, the plumbers, those kinds of things. Rosetta Design Group is the architect and the engineer in that scenario. And our customers are general contractors who have in employment people who can express and test proteins in the laboratory. Our primary customer is the small to medium-sized company that has on staff people that are able to do the design and testing. Cancer biologists, immunologists, lab techs, those kinds of things. And we provide to them, the blueprints. Our differentiator from other companies is that we, any IP, intellectual property that is generated is assigned to the client. We don't have milestone payments. We don't have royalties down the line. And that has a benefit for the client, obviously. They now own the intellectual property. It's a benefit for me because I don't have to wait through the 10-year life cycle of drug development and FDA approval in order to get paid. All the payment is upfront, and then that's it. So I have three parts to my talk. First, I'm going to tell you about my personal history. Then I will go through and tell you about proteins and protein engineering and how to be an architect for a protein. And then, of course, this is 1 Million Cups. I'll tell you about where I need help in running my business. So starting with personal history, some of you have already noticed my baby picture. I have similarities there still, and probably will continue to grow more similar. I am raised in New Mexico. Unfortunately, I was born in Texas, but moved very quickly to New Mexico. My dad worked for Intel for 20 some odd years. I grew up in Rio Rancho, went to Rio Rancho High School, where I took chemistry in Walter White's classroom before Walter White had his classroom. Graduating high school, I went to Hardin-Simmons University. I was pre-med. I wanted to be a forensic pathologist. In the days of the Sixth Sense, I would tell people, I'll see dead people. But I realized soon after that autopsies made me queasy. And so doing that for a living is not something that I thought was viable. So I wandered around, I looked for something else. I decided eventually that I really enjoyed my organic chemistry class. For any of you others who have done pre-med, organic chemistry is one of those weed out classes that people kind of don't like. So I'm a little bit odd in that respect, but it was the coolest thing. During my time at Hart and Simmons, I went and worked at a summer camp where I met a girl. And as happens when you meet a girl, you tend to follow them places. But first, she followed me to Vanderbilt in Nashville, where I did my PhD in chemistry. And it's there that I discovered protein engineering. And we'll talk about how you engineer a protein in the next section. But along with learning what protein engineering is, I learned that you could do that with a computer. And got involved with a software community called the Rosetta Commons that develops a software called Rosetta. And it was at that time that Rosetta Design Group was founded by another person. And I'll explain that when we get to the end of the timeline. So I learned to use the Rosetta software to design proteins while I was at Vanderbilt. Moved to Boston with Paul Revere at the Old North Church, where I worked for a pharmaceutical company for about 6 years. Ended up with 3 patents so far. Those also take a while to come through, so they're still coming. And 2 additional publications that sort of show what I can do in development of drugs and vaccines using computational methods. Spent some time there. While I was there, my wife was doing her PhD at Boston College. When she, being on the academic track, then needed to find a faculty position. That is not easy to do, and you generally don't just walk out the door of your college and find a faculty position right next door. So we were on a national search. Just so happened that the University of New Mexico was doing a faculty search, candidate search for something in her field. And it was a perfect time to move back and be close to family again. So that brings me back to Rosetta, to New Mexico, which is, and I needed to find a new job. At the same time, the original founder of Rosetta Design Group was ready to move on and achieve other goals. He felt like he'd achieved everything he wanted with Rosetta Design Group. And Rosetta Design Group needed a reboot. The original founder had been running it at about 20–40% effort. And I wanted to run it at 100% effort. And so that's what I've been doing the last couple of years, running it at 100% effort. But I think Rosetta Design Group can run at 300% effort or 500% effort. And so my goal now is to get more people. So that's sort of my history from birth to now. And I want to tell you, turn to the second part of my talk and tell you about what proteins do. So your genetic code is what, is basically your genetic sequence. It codes for proteins, but proteins are what do the work in your body. They're the enzymes in metabolism. They are the structural elements that give proteins, cells their shape and allow them to move, those kinds of things. And so they're quite important for the function of biology. Proteins themselves are made up of connected amino acids. And you can think there are 20 different naturally occurring amino acids that most commonly occur in proteins. You can think about those connections and the way they're shaped as very often said, beads on a string. I like to think of them like a rosary. Here in New Mexico, we kind of know what a rosary looks like. Each one of those beads would be like an amino acid in a protein. The amino acids that are nearby each other in primary sequence form other shapes, primarily alpha helices and beta strands, which pair together into beta sheets. In our house analogy, you can think about alpha helices and beta sheets as the 2x4s and other building materials that are the framework of your house. Those helices and beta sheets can then interact with each other based upon the sequence and form larger tertiary structures is what we call them. Those are like rooms of a house, for example. And then you can put your rooms of a house together in order to form the whole house, which has a kitchen and a bathroom and all those kinds of things. And all together, that house is a home where you can live and those kinds of things. Proteins have a function. This is hemoglobin. Hemoglobin moves oxygen in your red blood cells. It binds to a cofactor called heme, which is kind of what we see in the orange here. And so its function is to fold into a shape that allows oxygen to be transported around your body in red blood cells. If you change a single amino acid in the primary sequence, you can have a change in function in the quaternary structure. Next slide, please. And that happens in hemoglobin. Many of you have heard of sickle cell disease, right? And that is a mutation in hemoglobin that causes quaternary, a number of hemoglobin proteins to stick together. And that results in misshapen red blood cells. It just so happens that the first patients were treated with a gene therapy that has now been FDA approved just this week. So that's really cool. You can replace a bad copy of a gene with a mutation that doesn't work with one that is good. All right. The other place that I have had experience in understanding proteins based on their amino acid sequence, or one other place, is in the generation of and study of potential vaccines. I participated in 2010 in a study with collaborators of how humans respond to bird flu vaccines. So a little bit of life cycle of flu. There are like 4 or 5 versions of flu that infect humans, and that's what we have as seasonal flu. There are like, I don't know, dozens and dozens and dozens of flus that circulate in primarily wild birds, waterfowl, bats, those kinds of things. And so the possibility that flu could infect humans from birds could create the next pandemic. So understanding how we might respond to that, preparing in advance, is quite important. So that's kind of what we were doing in this particular study. We looked at using very high-powered microscopes, the interaction of an antibody which binds to bird flu, H5N1, to a particular protein on the surface of flu that's used to enter our cells called hemagglutinin. There's kind of this unintentional theme of heme and hemoglobin and hemagglutinin, but it is unintentional, but it happened. Yeah, so in this like marshmallow shape that you see on the upper right, that is a negative stain electron microscopy data that you see of an antibody binding to hemagglutinin. What we found in our study is this K193, which you see on the far right in magenta color. That residue is particularly important for binding of this antibody. Some flu strains have an R at that position, and they can escape this antibody. So understanding that this particular site can be escaped can allow us to design vaccines that are less, well, they're more robust and less likely to, be ineffective. One thing that our team could have been asked is to design an antibody which is robust to both the K residue, K amino acid, and R amino acid. And I've done that for a number of other influenza antibodies that bind in different strains or at different places. And I've also done that more recently for RSV for treatment in infants. Next slide, please. So at Rosetta Design Group, our key services are, we have 4 primary services. One of those is contract R&D. And that would be doing things like redesigning antibodies so that they make better drugs, or so that we can understand how to create better vaccines. In that case, as I mentioned at the beginning, all of our intellectual property is assigned to the client company. So our expertise in protein engineering, the architecture of proteins, but it's their IP. And that is certainly something that the companies like. See, we do consulting. A lot of people are intrigued by what they read in the scientific literature on protein engineering. And in particular in the artificial intelligence age. This field is like many other fields and has gone through a major revolution in the last 4 or 5 years. So that's one of the things that has been a challenge keeping up with, but it's also led to, significant amount of interest in services like this. We do consulting in places where people aren't quite sure how they're going to use these technologies, but they think they want to use them. And so we consult to lead to contract R&D. I also offer software support services. I've been doing this for about 15 years. And take that back 19 years, 20 years, something along those lines. I have a lot of experience with this software, in particular the Rosetta software, which is where we get our name. And so people that don't have, experience in this software might need some help. This is in particular, people who are familiar with other computational methods in understanding biology, bioinformaticists, for example. Paul, you want to buy some software support services? And then I also do customized software training. That would be, again, for people who are maybe not even confident enough to run the software themselves and don't need the software services, but they are actually needing training to get, just that first step. So that's one of the other areas of our key services. Where I need help in running the business, I'm a trained scientist, and the business side of things is something that I'm trying to pick up on, and that's one reason I come to 1 Million Cups each week. I need to reach the right client and also be able to close. What I've tried to do is attend conferences. I'm also a participant in an organization of conferences. I gravitate to the people who do computational science at these conferences. And they're not the ones who need my services. So I need to figure out the strategy, the script, those kinds of things, in order to reach out to these other people and then close them in the services that I have. I've done a website review. Everybody go to rosettadesigngroup.com. Look at the wonderful website that Noventum has put together. It is live less than 24 hours. So if you find any mistakes, wait until next week to tell me so I can just bask in the glory first. And then we had a problem with our Google business profile. Rosetta Design Group used to be based in Vermont. When I tried to move it here, I messed it up and they told us that we were temporarily closed and then permanently closed after it got suspended when I tried a few more things. I finally won my battle against Google, and that is now corrected. We are an Albuquerque area company and no longer listed as closed. So that's what I've done. What I plan are, blogs, LinkedIn posts, those kinds of things. I need to get out. What I understand is that I need to get out to my network, and primarily of people who are maybe adjacent to my network of protein engineers and software, people who use computational software to engineer proteins. Those are the people that are going to actually come to me and use my services. They're the experts in the wet lab, those kinds of things, the cancer biologists, the immunologists. And then academic collaborations. The currency for our business is scientific publications, patents, those kinds of things. Got to keep that going. And so I've got a number of collaborators that I'm hoping to work with in order to keep those kinds of things. It's almost like pro bono work, but it should result in additional business because I can share it all publicly. All of my other work is behind an NDA. I can't, or it's significantly difficult to share publicly. So that's my short-term immediate need in order to, feed myself, those kinds of things. Right now, Rosetta Design Group is really Rosetta Design Me. I'd like it to be, as I said, more than one person. I like to work with other people. I like to discuss science. I like to, bandy ideas around, those kinds of things. I think there is enough, there's plenty of work to have other people. But that sort of takes a little bit of, I need to build up some confidence. Business forecasting has been a challenge for me. I've read a number of books. In this particular industry, we have fewer large contracts is how we, there were some years I'll have 4 contracts. And that's survive on that for the entire year. It's a little bit, I am having a challenge taking my books that describe cash flow in a t-shirt business or a bakery, right? And applying those to what I'm doing here. And then hiring, right? Hiring somebody is quite, like you basically have a big responsibility. So I need to understand, in particular, my cash flow so that I can maintain that responsibility to the people that are being hired. And then my exit plan out of this company is not to get bought up. I want to do this for the next 20 years until I retire. And so what I've been thinking about is, hiring that leads to partnerships a la law firms where they take on, an associate and they pay him as an employee, and then they promote them to partner and they have equity in the business. And eventually my partners are going to buy me out and I'm going to retire. That's my vision, but I don't know how to get there. I don't know what the contracts look like. I don't know what the steps are in the first couple of years. And also giving away equity is like, you never know about doing that, right? So I need people to talk to about those kinds of things. So I told you a bit about my story. I told you what protein engineering is, how changes in amino acids in the protein sequence, which comes from your genetic, your DNA, affects protein function and how we can engineer that. And then I told you, of course, where I need help. And so first thing first, all of these images were generated by the designers at Noventum. I think they're amazing. There are many more on the website if you want to look at them. I am advertising for Noventum here, but I got to give credit, right? I love them. And with that, I'd like to take some questions.
Okay, folks, don't be shy. Come on up here. There's got to be some questions. So, I'm here to demonstrate etiquette. Point the microphone directly at your mouth. Don't do this or no one can hear you, right? So point it right at your mouth and say who you are and where you're from. I'm Paul Sauter with Equity. Now, we had a lot of really good conversations heading into this, and I promised you a curveball question. This is like the last thing they ask you in a thesis defense. Okay, so synthetic biology is proceeding, and probably in your lifetime, we will have the ability to add amino acids that are not currently in the repertoire to proteins that are synthesized by synthetic living things. If you could add a single type of R group that's not currently represented in the repertoire of amino acids, what kind of an R group would you like?
This is a fun one.
Yeah.
So the Rosetta software can model these non-canonical amino acids. We have hundreds that we can model, and they do a bunch of different things. So I'm going to turn this around on Paul because he told me that he's had a curveball question. What do you want your R group to do? Good question. We could have it light up. We could have it explode. It could be a warhead. Maybe you hit it with UV, something like that, a laser. And so you target that protein to a cancer cell, and then your non-canonical amino acid explodes and kills the cancer cell.
Mhm.
We could have it do a bunch of other different things. Do you have a use case for your art?
Well, I'm just going to take an example like there's selenocysteine, right, which is a real oddball, substitution. And I'm thinking things that have weird metals or that are, have to be in an anoxic environment to work, but could do novel chemical reactions that current enzymes don't do. So that would be my interest.
Well, are you saying
Very
you
cool.
want a catalyst?
Yeah, for example, yeah. Yeah, a catalyst that's not in the current repertoire of amino acids.
So one challenge in protein engineering for enzyme design is that enzymes have a limited amount of chemistry that they can perform. We only have 20 amino acids. They're negatively charged, positively charged, polar, apolar. But if you could add something that had a metal involved, and enzymes do have metals, but if you could put that in an amino acid, or you could use something like boron as a catalyst to do other chemistry that we know from, pots, beakers, those kinds of things. Like if you could do that kind of chemistry in an enzyme, that would be really cool.
That's what I want to see. Thanks.
Thanks, Paul, for getting us into advanced chemistry. David, Dr. John Patrick, I'm a closet nerd. If people don't know me, I used to actually work in simulation and in the sciences. And so one of the things that really kind of struck me about your presentation is that you get a chance to actually do simulations and produce working models of the activity of the proteins.
Mhm.
So can you kind of explain like how this would benefit the potential customer? Because these are kind of like boutique, small businesses. You're not working for the who is it? The main branch that does the chemistry for cancer, like when we had the COVID pandemic.
NIH.
Yeah. So you're working for very small companies. And so how do you help assist them to get them to a point where they're producing viable vaccines?
Yeah, so Rosetta Design Group has had contracts with, NIAID. My former partner, the founder of RDG, was an employee at NIAID, worked under Fauci for a while. We've also had contracts with all of the big, like top 5. I don't know if all is the right, but we have most of our Pokemon set of the very large companies. I stole one, it's not mine, but we help by streamlining their discovery efforts. So, and then improving the quality of the discovery. Development of a drug takes 10 years. And estimates now are $1 billion. If you get it right very early on, it's going to survive all the way through that clinical trial process and make things happen, and be more likely to be approved. So our knowledge and tight engineering, quality engineering at the very beginning can be worth a whole lot of savings as you proceed through the development process.
So it's kind of a race to the patent if you're selling to the company that's producing.
Yes, always. It's and that's why I mentioned NDAs. NDAs are very right. We don't discuss anything before signing an NDA or a CDA, and I can't publish any of the work until the patent comes out. And even still, I don't own the IP. Right, it's my shtick. I give it away, so I have to ask permission to talk about these things, and they may not want to talk about it until they get all the way through FDA approval, because even the discovery process is analyzed when a drug goes to FDA approval. And there could be something, some secret or whatever that might cause a regulator to ask questions. And then it could come all the way back to me. So I can't talk about a lot of this stuff for about 10 years.
So you're kind of playing a long game in this industry. And then at the same time, we're in a time on the planet where I guess chemistry is exploding in viruses. Like it's kind of unprecedented now with the environmental changes and the chemistry that's in the water table and how it's affecting things. So how would that affect your work and actually increase your ability to create new product.
So recently with the computational design work, the field has been able to design proteins that bind to virus sites. We have also, with basic science research, been able to utilize previous studies to advance the generation of vaccines. COVID vaccine is one example of that. Does anybody remember the actual name of the COVID virus?
Sorry, COVID-19 or?
SARS-CoV-2. That implies that there's a SARS-CoV-1, right? So in SARS-CoV-1, they studied this virus. It's related to SARS-CoV-2. They took the protein that allows entry into the cells, and they looked at its structure. And this protein, what it does is it kind of reaches up with two arms and then three arms, and then like pulls the virus inside. And so it's got this function that has a couple of different shapes. Your immune system can only recognize the shape with the where the arms are kind of reaching up before it pulls it into the cell. And so you have to, there's a mutation that can be made that fixes the SARS-CoV-2 protein in the conformation that is useful for the immune system to recognize. And so that is basic biology that was studied before that allowed for a vaccine to be developed in a year. So that's one of the things that we can do. And we can predict those kinds of mutations with the software that I use. And then we can also just predict new proteins that bind. Antibody design, antibodies are my area of expertise, is hard. There's a company that just got $1 billion Series A, $1 billion Series A that can do antibody design, or reportedly can do antibody design from scratch. So that's pretty cool. Like there's some amazing things that are coming in, in the pipeline that can really advance our knowledge. The other thing that your question kind of led me to was just basic science. The group where I did my influenza work that I presented here, they now have a list of like 30 viruses, and they're funded by the government to discover antibodies from humans to all those 30 viruses so that we have those on hand. And these are things that, you normally wouldn't hear about. Ones that you would hear about are like West Nile virus, Ebola, chikungunya. And then there was a whole bunch of others that like I didn't even know about, 30 or 40, something along those lines. So basic science is the way we do the stuff.
Well, thank you. There's plenty of other questions here, and I could talk to you for hours, but we appreciate you. Great presentation.
Let's continue to talk.
And this is great. And it's amazing that we have people like you in Million Cups on Wednesday morning. Okay. You've demonstrated two things. You have a request that is, I want to connect with the decision makers that would hire me. You've demonstrated two really important things. One is explaining your work to people like me. I'm a scientist. I was a Sandia Labs simulation guy, but mechanical, electrical stuff. But, so you could explain it to a mixed group of people with different expertise. You can talk to somebody in your field and explain it. My question is what have you done to think about that decision maker and how you would go about expressing what your unique things are with those decision makers? And what have you done to prepare yourself to explaining yourself quickly to those people?
So I typically establish credibility, right? So I've been doing this for 19 years. I'm part of a community. I barely talked about the Rosetta Commons, but that it has been the leader in this field for 20, 25 years. And then I always mention, our IP assignment practice. And that usually perks up the ears. They realize that they're not going to have to bring in their business development groups in order to do the basic discovery work and early development work that that they're interested in working with me with.
I guess maybe even very basic, do they know like what the Rosetta group is? Do they know which of their scientists you would be interacting with? Do they know which of the pieces of their business that you would be working on? Or do they just know this general idea, hey, here's a guy with patents?
Most, even small to mid-size biotech companies have a protein engineering group.
Okay.
And they're using the classical methods, yeast surface display, those, rational design, linkers, linking two things together. Those two different proteins that wouldn't naturally be linked together. And those protein engineers are routinely employed. And where I would be coming in is the place where, you don't need somebody who's an expert in computational work, maybe on staff all the time. And so I would fill that role. The decision makers, the scientists are usually the ones who say, I can't do this with my current methods. I need somebody else. And then they're going to convince the decision maker. So it's almost the low guy that I need to reach, and then I need to convince the decision maker that there's room in the budget for those kinds of things.
Interesting. Have you done any kind of like with the businesses that you want to approach, taken those people that you can talk with and try to understand where they are in the business and do some business intelligence to get that connectivity and that issues out there? I don't know.
I usually do a little bit of Googling around on a business before a call. But given that it is, like JP hit on, a race to the patent, they're not publishing on a lot of these things. You can very often tell what their technology is, but you can't really know where they are on particular systems or goals for what is eventually going to become the drug. And so it can be a little bit hard to look around. Mostly where I'm looking is, did they recently get significant investment or partnership that has been published for, $400 million. And then I can charge them twice as much as I normally would because they've got plenty of money, kind of thing.
Well, thank you. It sounds like you're kind of moving and you're in that direction. I guess I mean, for that thing, it just seems to me that would be your keystones is, you said, I want to approach people that I'm not approaching. And it's talking it's figuring out who you want to approach and then explaining yourself in the context of what they know.
That's perfect. Identify the decision maker, make myself communicable to them. All right.
David Bronsteiner with Noventum. Thank you for all the business. My main point is that I wish I had hired my first person maybe 2 to 3 years earlier than I did. And you were talking about your cash flow and your profit and loss in your balance sheet they have a degree of interchangeability. So what do I mean there? I mean that if you're sitting on a war chest of cash, then maybe that can cover some holes in your monthly or quarterly cash flow. So you might consider attempting to save up enough money so that your level of risk is acceptable, that you can cover the person's salary for a certain amount of time, that maybe you have some holes in your contracts and then have some internal projects that you can have them working on. And that's been generally my approach with Noventum. It's a lot harder to build up a war chest when you have 3 kids and 2 cars and you can't just ride your bicycle everywhere. But, that helped me, and just understanding how those 2 things are related and interchangeable to some certain degree is what pushed me towards some of my first hires. So I hope you can do it. And again, thank you very much for all your support over the past year and a half.
Thanks. On my personal finances side, we have our war chests, we have our savings, purchasing savings. I think we're good up to 6 months. The business, I've got my bank account and I just kind of spend on it. I haven't actually put a budget in place, and that I think is probably what you're saying that I need to do.
It might help you because then you could pull the trigger on hiring somebody when you have enough for their salary for the next 4 months in the bank.
Okay.
Morning, John Borsman, JV Management Consulting. Hi. You made a remark in passing, it seemed to me like a main point. And if I understood correctly, you said there's a lot of work out there. And I'd like to hear a little bit more about, well, if there's a lot of work out there, what's the barrier between you and getting that work?
I think it's making enough noise to be seen among all of the others who are claiming to do this work right now. There are a lot who will take the latest open source software and put it up on a server and say, look what we can do. But they don't actually know what a protein, a functional protein looks like. There are a lot of in this particular area, there's a lot of art that goes with the science. The algorithms are good, they're not perfect. And so you have to be able to look at it. So a ton of groups are doing these other things. There's a bunch of, there's a bunch of startups right now that are claiming to do wonderful protein engineering with computational prediction. And of course, they make a lot of noise. The Y Combinator funded or participants make a ton of noise. So I think that's where I need to be, is making a lot more noise and being heard above just the fray of other people.
I see. So is it right to say there's a lot of work and there's a lot of competition? Good.
There are a lot of other people doing this. They have a lot of interest as well. And so I think there's a lot of work. And I need to be seen alongside all of the others in order for people to know about us. It also helps that we're no longer listed as closed and we have a new website. Sorry.
That's good. I guess my last question is related, which is how much of the market presence do you think should be or is about not just protein engineering full stop, but a set of niches of highly specific and maybe innovative parts of that market?
I'm not sure I understand.
Let me try
I
again.
tried.
No, let me try again. What I'm picturing is that there's not just knowledge about protein engineering, but there's knowledge about protein engineering in a whole range of highly specific circumstances and situations, and maybe some of them right at the research frontier, which is maybe related to your interest in publishing and so on. And so that's what I'm wondering, is if it's not just protein engineering, but we're not just one of many protein engineering firms you could hire, maybe with some extra experience and skill, but we are the world leaders in industrializing these 8 particular things.
Yeah, I've always described myself as a utility man in particular the Rosetta software. Started out my PhD doing enzyme engineering, and then I moved to antibody engineering. Those are 2 big places. But there's also like your interleukins and your other your immuno-oncology proteins like PD-1 or PD-L1. Those kinds of things are useful. Your kinases, right? I think, and then you have the different technologies that I could demonstrate expertise in. De novo protein design from nothing is sort of a new area. I think one of the things I need to do is get out a blog post that says I've implemented software in-house that says that now I can do de novo protein engineering. Here's where I think it's already great. Here's where I think could be better. And then prove, hey, I know the shortcomings of the software. I know that it's going to work for your case or not. And we can decide right away whether or not to pursue a partnership. I'm not just lip service saying that this technology is great. I actually know how to use it.
Hi, David.
Hi, Dr. Norm.
Hey, I'm Dr. Norm with Dr. Norm's Connections in the dementia defense business. First of all, I want to acknowledge you for your appreciating the audience by having the captioning off to the right upper side there, because there are more people here than just me that appreciate the captioning. So thank you for doing that. Secondly, I can just sit here and listen to you forever because I did take organic chemistry and studied the Krebs cycle you don't know what the Krebs cycle is, it's a process where energy is produced in the mitochondria to create energy. And what it looks like, if you look at the Krebs cycle, looks like somebody's taken a bucket of spaghetti, thrown it against the wall, and it's splattered all over the place, and every single connection matters. So the question I have for you, futuristic thinking, since the Krebs cycle takes place in the mitochondria, and our mitochondria continue to break down, dissolve, and don't function as well as they'd like to as we get older, is there any kind of possibility of doing some sort of a protein synthesis or modeling to help restore and slow down the mitochondria process so that we can live longer and that kind of stuff? That's pretty futuristic, and we may not have time for you to go into a full dissertation about it, but a quick answer.
One of the biggest challenges in drug development is the targets. And so I recently asked Paul for targets. He gave me one off the top of his head because Paul's amazing. But the other challenge is the technology, and proteins have to have a way to get into the cell, unlike your small molecules like aspirin or something like that. Aspirin has 9 carbons, 8 hydrogens, and 4 oxygens, something along those lines. It's very small. Proteins have thousands potentially of carbons, hydrogens, nitrogens, oxygens. They don't cross cells very readily. And getting, the mitochondria are inside the cell. You got to get into the cell, got to get into the mitochondria. And there are technologies that do this. It's harder. So you have, I think the big challenge will be, one, identifying the protein that you want to treat that is going to minimize the aging of the mitochondria, and 2, getting your drug there.
Just a thought.
Yeah.
Thanks.
Hey, David.
Hi.
Thank you so much for helping me with my Excel spreadsheet way back when. So I teach sales, and I heard you twice say, I need to close. And I have no doubt that you are brilliant. I mean, you're talking to us, and many of us are going, I have no idea what he just said, but he must know because people are nodding. So I would love to have a conversation with you about how do we sell. And I heard you say, well, what I need to do is make more noise. What I need to do is get in front of the decision maker. I need to do all these things. And what I would encourage you to do is learn to ask the questions of, like when Paul said, what would you do with this? And your question was, what do you want it to do? Go there more often when you're talking to someone.
Solicit more information.
Yeah, what do you want? What would that do for you? When would you want that? How much of a budget do you have to get that? And if I could show you how to do that, could we sit down and talk? Don't tell them everything until they've given you money in hand. People love free information. Don't give it away.
Okay,
So just ask more questions and listen.
thank you.
Sure.
Send him a bill.
Hello, Mary Martinez Pino with More Than Organized. What Barb said, what Michael said, what Brian said, what Paul said. I can't remember who else was up here, what Norm said, all good stuff. But one of your main questions was how to apply the information you're learning about business to your scientific endeavor. And I think that is a conversation to be had, but thinking about it from how you want, setting up that foundation of how are you going to do sales? How are you going to find the clients? Who's your ideal client? What's your way of getting out there to be the thought leader? You didn't have Reddit or Substack up there. And that's probably a really good place for you to explore as well. But just figuring out how to apply what you're good at and explaining. And I was telling Barb, I'm surprised I understood so much of what you said because I do not have a science background. So I think you have some real possibility of becoming a thought leader without giving the store away, and then they look for you. And I feel your pain on the Google issue because I just did it too.
Yeah, when you go and get a PhD, you have 2 choices. You're either going to go the academic route, be faculty at a university, or you're gonna go to industry. And industry is typically seen as the lower route, the less prestigious route, and it's a culture that I work hard to change in my academic people that I know. But a major reason I didn't go the academic route is that I don't like to write. And in order to put something on Substack, usually you have to write. I know you're gonna mention ChatGPT, but.
No, I'm not actually. But I will do speech to text. And then getting an editor to help you fine tune it before you post it. But that's the beauty of posting on places like that. You don't have to write a fully formed article or thought. You can put out a supposition or an idea or something that intrigued you and start a discussion. And that's where you can shine.
It's a very good point.
Yeah.
I don't mind editing. It's that first draft that's killer to me. But
Yeah,
speech
you
to
should-
text, fix it.
speech
I
to
can give
text.
talks, prepare a scientific talk,
Yeah.
give it, and then remove all my ums. I'm a
Exactly.
lot better about that. I'm sorry, they still exist.
You just pretend that it's because you're smart and you have to slow down your brain to get it out of your mouth.
We got to call time here. So, 2 questions. What can this community do for you?
I asked about, ways to get in front of people, to close, those kinds of things. There was lots of good advice here. And then, long-term hiring, cash flow, those kinds of things, good advice there as well. Yeah.
And then the second question, Proline or Serine? I mean, recreation.
I have a bias against proline. The
Yeah,
protein
the
I
helix
worked on,
breaker, yeah.
it broke my
Broke your
protein.
helix,
So
yeah.
I have an implicit bias against proline, which I know I'm aware of.
Oh, good, good.
So I make sure that it doesn't carry through in the rest of my scientific work.
What color is that?
It is green.
Green. So you're a red. You're okay.
No, sorry.
You are. a
The
green.
color that I like, I'm a green person.
Okay.
Terrific.
And Lisa, take us out.
Well, I'm gonna let you take us out. Thank you so much. Give David a